Welcome back, future lifesavers. Last time, we dove into the primary survey with Zeke and Anya. Now we're about to get cellular. That's right. We're zooming in to the building blocks of life. Grab your microscopes, and let's tune into First Responder Radio. Captain Dave's about to take us on a wild ride through the human cell.
What's up, Bio Warriors? Captain Dave here, coming at you on First Responder Radio. Today, we're going subatomic with cellular biology. It's like, Honey, I Shrunk the EMTs, but with more science and less Rick Moranis. Let's eavesdrop on our dynamic duo and see how they handle this microscopic mission.
All right, Zeke, pop quiz time. What are the main components of a cell?
Oh, that's easy peasy lemon squeezy. We've got the cell membrane, nucleus, and cytoplasm. It's like a tiny city, and the membrane's the city walls, the nucleus is city hall, and the cytoplasm is all the stuff in between.
Not bad, kid. Now, thinking about our last stroke patient, why is cellular function so crucial?
Well, in a stroke, cells are like people trapped in a blackout. No oxygen means the mitochondria, the power plants, can't produce energy. And without power,
the city goes dark. Good analogy. Now, what about ribosomes?
For $500, Anya, they synthesize proteins. They're like the city's construction crews, always building new stuff.
You're on fire today. What about the endoplasmic reticulum?
And on your left, you'll see the endoplasmic reticulum, the cell's very own subway system. It aids in transportation, just like how we transport patients, but on a microscopic level.
You've got a unique way of explaining things, Zeke. Let's dive deeper. What's the Golgi apparatus do?
The Golgi apparatus, that's like the cell's post office, right? Packaging proteins for delivery.
Exactly. And lysosomes?
Behold, the lysosomes, the cell's own hazmat team, breaking down waste with their mighty enzymes.
And the nucleus?
Ah, the nucleus, the brain of the cell, the big boss, the head honcho. It's got the DNA and calls all the shots.
Perfect. Now, let's scale up. What are tissues?
And here we have the tissues, folks. Groups of similar cells working together like a well-oiled machine. Take cardiac muscle tissue, a team of cellular athletes pumping blood like champs.
And organs?
Organs are like the cell's version of the Avengers. Different tissues assembling to form a superstructure. The heart's got muscle tissue, nervous tissue, connective tissue. It's a regular tissue party in there.
You're really grasping these concepts, Zeke. How does understanding cellular biology help us in emergency medicine?
Well, when you think about it, everything we deal with comes down to what's happening at the cellular level. Whether it's a stroke, a heart attack, or trauma, we're really trying to keep the cells alive and kicking. It's like we're cellular bodyguards.
Absolutely right. And understanding how cells work helps us grasp how different treatments work too.
Oh, like how oxygen therapy is basically us throwing a lifeline to gasping cells, or how medications are like secret agents infiltrating cells to carry out their missions.
You've got a flair for the dramatic, Zeke, but you're not wrong. Now, thinking about our stroke patient earlier, how might understanding the circulatory system at a cellular level inform our treatment?
Well, in a stroke, it's like a cellular traffic jam. A clot or bleed blocks the blood highways, cutting off the oxygen supply to brain cells. That's why time is so critical. We need to clear those roads ASAP before the brain cells start throwing in the towel.
Excellent point. And the nervous system?
The nervous system is like the cell's internet. Electrical signals zipping around, controlling everything. In a stroke, it's like some of those internet cables get cut, disrupting the signals and causing those symptoms we see. Weakness, speech problems, the works.
You're really putting it all together, Zeke. I'm impressed.
Ambulance 26, respond to 4 on 56 Oak Street. Possible cardiac arrest.
Well, looks like we'll have to continue this later. Ready to put all this knowledge into practice?
Absolutely. Let's go save some cells.
Remember, in cardiac arrest, we're racing against time to prevent cellular death across all organ systems.
Right. Every compression we do is like a cellular crowd surf, manually circulating blood to deliver that sweet, sweet oxygen to the cells.
That's one way to put it. What's our ETA?
GPS says 3 minutes out.
Perfect. Let's run through our cardiac arrest protocol one more time before we arrive.
And there you have it, folks. cellular biology, and emergency medicine, all wrapped up in Zeke's unique brand of edutainment. Remember, while Zeke's analogies might be a bit colorful, the science is dead serious. Understanding cellular function is key to providing top-notch emergency care.
Absolutely, Dave. Zeke might have his own flair, but he's got the basics down pat. From cell components to organ systems, it's all interconnected in the complex machine that is the human body. Now here's a pop quiz for you listeners. How might understanding cellular respiration help you in treating a patient with diabetic ketoacidosis? Think about it, and we'll discuss in our next segment.
Great question, Don. And let's not forget the importance of continuous learning in EMS. Notice how Anya keeps challenging Zeke with new questions? That's the kind of curiosity and dedication to knowledge that makes a great EMT.
Spot on, Dave. In this field, learning never stops. It's not just about memorizing facts, it's about understanding the why behind our treatments.
Speaking of treatments, let's talk about that cardiac arrest call they're heading to. Any advice for our listeners, Don?
Absolutely. In a cardiac arrest situation, remember that every cell in the body is crying out for oxygen. High-quality CPR is crucial to keep that cellular engine running until we can restart the heart.
Great point, Don. And remember, folks, while we're focusing on the cellular level today, never lose sight of the big picture. We're treating whole patients, not just their cells.
Exactly. Now, listeners, here's your homework. Take a common condition you might encounter in the field, let's say anaphylaxis, and try to explain it at the cellular level. Bonus points if you can make it as entertaining as Zeke's explanations.
And that's a wrap for today's lesson, folks. Remember, in EMS, knowledge is power, but understanding is key. Keep diving deeper into the why behind what we do, and you'll be better prepared for whatever comes your way.
Thanks, Dave. And thank you, future lifesavers, for tuning in. Next time, we'll explore how cellular biology relates to pharmacology in emergency medicine. Until then, stay curious, stay prepared, and keep those cellular cities thriving.